Okay, so this is section 5.2, taking antiderivatives for things that involve natural law. And it's really pretty straightforward, at least the first part of it is. When we start with this piece of information, the derivative of the natural log of x is equal to 1 over x. And we are limited to x being greater than 0 because ln of x is greater than 0. Yes? The answer to it, 1 over x can be greater than 0 or less than 0. But ln can only have x's that are greater than 0. So what we do is to try to expand our ability to look at this just a little bit, is we consider the natural log of the absolute value of x. And so if we were to look at that graph, this is the ln of x right here. And if we were allowed to plug in negative values of x's, because then the absolute value is going to turn them into positive values, then that second half of the graph is going to look like this. It's going to be a mirror image. And we then are working with every number except x equals 0.
Wait, okay. Why, if that's absolute value, why is it equal to 0?
It's absolute value of x. So like if I said, what's the natural log? Like if the natural log of 2 is something, a, some number. And I said, what's the natural log of negative 2? Well, that doesn't exist. You can't take the natural log of a negative number, okay? But if you put absolute values on it, then the natural log of the absolute value of negative 2 is also, well, it's whatever the natural log of 2 is. It's the same number. So you get basically the same graph, only flipped over, okay? Give me your image of it. Okay, and I think y'all remember that, like just the basic concept of the absolute value of a function. You were asking about this. Would be the time where it flips it up like that. Whereas if you do the absolute value of the x, you get the mirror image on the other side. I think that's what's happening when you get those two stuff. Okay, so if we define it as the natural log of the absolute value of x, it just expands our domain. We can look at things besides just positive. That answer is still going to be 1 over x, and then we've only got the restriction that x cannot be equal to 0. Okay? So we can now take the antiderivative of this function, and as long as we put the absolute value on there, then we can work with all these different values of x's. And that's true for functions, other functions as well. So using that, we're going to work our way back now to take the antiderivative. If we restrict this to x is strictly greater than 0, then the answer is ln of x. But if we make no such restriction, then the answer is ln of the absolute value of x. Okay? And our only restriction is that x can't be 0. This allows us to deal with negative numbers as well as positive numbers. Yes?
If I were just to do that, if I just saw that problem right there, I wouldn't change ln of x. I would do like 1 over...
You would do this, right?
Yeah.
Okay, well, let's do that. So what do I get here?
0.
0. And what do I get here?
1 over 0.
Right, where we run into a problem. So the power rule doesn't work on this one. Did I say? Okay, so if you accidentally start to do that, hopefully you'll recognize, oh, wait a minute, I can't do it. Okay, that's not going to work. Okay? All right, so, this seems fairly, that's like all there is to it. The derivative of ln of x is 1 over x. The antiderivative of 1 over x is ln. You have to put those absolute values on here, okay? Unless you're setting up some sort of restriction. So the rest of it then is just recognizing other forms, basically problems that we're going to have to do substitution on, okay? Not always substitution, but we're going to have to pull with the problems a little bit, okay? So the most straightforward would just be a constant multiplier. And you need to recognize that you can pull that constant out. Like this. Okay, and so this answer would be 2 times the ln, the absolute value of x, plus c. And then one of the other things is that recognizing what it might do to an answer with all those ln rules that we've got. Yes? So what would you do if you have a, what could you do if you have a 2 right here? You could square it. And you see that if you square it, then you no longer need the absolute value on it, because when x is squared, it's always going to be a positive number anyway. And so the absolute value would then not have to be there. It could be there, but it doesn't have to be there. Okay? So you're going to find when you're looking up answers, and sometimes there's an absolute value, and sometimes there's not, and you need to ask yourself why were they allowed to get rid of it. Okay? Now, if the denominator is not x, okay, one of the new substitutions that we could try is now to let u equal the denominator. We've let u equal things that are squared or things that are cubed. We've let u equal the argument of a sine function or the argument of a cosine function or something that's under a square root. And so one of the new things that we're going to try is letting u equal whatever is the denominator. Okay? Because then if you get 1 over u, your antiderivative will be the ln. Okay? So du is just dx. And I do my substitution, I'm going to pull that 3 out. And it makes a very straightforward substitution. Okay? So then you've got that negative 3 and the ln of the absolute value of u plus c. Resubstitute. That's the value of x times 1 plus c. And this is a perfectly good answer. Just a recognition that they might possibly do something with that negative 3 and make it an exponent. And that's a possibility. Okay, you don't have to do it. Sometimes they do it, sometimes they don't. Okay. Or x plus 2. This will be the same problem that I have in front of me. Okay, so we're going to just practice this, letting u equal the denominator and seeing what happens. And when you get du this time, it's not just dx. Du is going to be 4dx. So you got that extra multiplier there. And this is when we did solve for dx. Look like this. Some of y'all didn't have to show that other step when we were deep in the substitution problems. So this is going to be the antiderivative of 1 over u. I'm going to have a du, and I'm going to have a 1/4. Everybody see? Yes? Okay, so, at this point it's super easy. What's the antiderivative of 1 over u? The ln of the absolute value of u. Go back and resubstitute whatever they gave you, which was 4x plus 2. And again, it's possible that they could write that to the 1/4 power. My instinct is that most of the time when they make this into an exponent, it's usually when it's a square or a cube or a third, something easy, a positive power. But if it were a 1/2, if that had been a 1/2 right here, then this might have been a square root. Right there. That's a possibility. I think that might show up somehow too. Okay, stop counting. 1, 2, 3, 4, 4. All of a sudden I just started writing an example. As long as all of the homework problems are this kind of problem, they're easy. You let u equal the denominator and see what happens. It's when they're mixed in and you have to recognize it that it becomes a little bit more challenging. Okay. All right, so we're going to try again. Let u equal that denominator. The key here to recognizing u equaling the denominator is that there's not another composite function going on there. There's no square root of some stuff or sine of some stuff or a lot of stuff squared. The only thing that's squared here is just the x, and it never does any good to let u equal x, right? So that's kind of your clue to try letting u equal the denominator. And du then is 2x dx. And is that going to work for us? Yep. We're just going to end up, that's a 3, this is a 2. We're going to end up with some constant multiplier on the outside to make it work right. Sometimes I have to just do this. Sometimes I can do it in my hand, and sometimes I have to actually write it down. And I just, you be the judge of when you need it. The x's are going to cancel out, and I get it pretty fast. Questions? Good. Okay, Okay, so this is going to give us 3/2 the ln of the absolute value of u. And then we substitute in the ln, the absolute value of x squared minus 2. Okay, so everybody get the idea? Right, in the simplest cases, they're really pretty simple. Sometimes they are just a little bit more complicated. This one doesn't look any more complicated. In fact, it looks kind of like the last problem did. Yes? But there's something about this problem that I've told you. When this happens, you can always consider doing a specific thing at the beginning.
Well, get to the denominator and letting you use x and do anything to use the substitution.
Okay, well, letting u equal x isn't going to do anything, so that's not going to be our choice here. So I see that? But what I want you to think about is something I've told you, that when a certain thing happens, and it happens here, you should always think about whether you want to do this specific step before you take the antiderivative. Yeah? It has to do with the denominator being a monomial, meaning there are no pluses or minuses, it's just a single term. Am I right? That's right. You had it right. What was it? For division. Separate this thing out into its pieces using distributive property for division. So consider whether this would be a better way to look at this problem. Right? It's one of those things that keeps popping up. And the difference between this problem, number 5, and number 4, is that this denominator is a monomial. Okay? Which makes this a more reasonable thing to try. So this becomes the antiderivative of 1/3 x. Is that right? Minus 2/3x dx. Okay? And this then, or x/3 for the first part, if you like that better. That can be 1/3 x, or it can be x/3. Okay, and then now what you got to sort of build into what you've learned to recognize is that I don't need to do any weird substitution for this one and this one, so this one over here. This one is going to be ln because it's 2/3 and 1/x. Y'all see that? Okay, so this first part right here will just be x squared. Yes? We have a 1/3 there, and then we're going to have a 1/2. And this one's going to be 2/3, the ln of the absolute value of x. Follow? And I think that it's just, you want to really try to recognize these sort of simple ones like here. So that's the integral of 2/3 times 1/x. Kind of seeing it that way might make it a little bit easier to recognize. And it's new, so it takes a little time. So this 1/3 times 1/2 is 1/6. 6, 7, 12. My last example. Okay. Okay, again, if you know that every problem you're doing is going to be the u substitution, let u equal the denominator, everything's super easy. And that's not going to be the case. You're going to have to look in the problems and figure it out. This looks like one of our old ones. You can let u equal the whole denominator. But a little thought will show you, even without you actually writing all this down, that that's way more junk in the du than I'm going to want to deal with. Does that make sense? Okay, so while I'm not saying it won't work, I'm saying it seems like maybe this is not the right path. Does that make sense to everybody? Because there's just too much stuff here. There's not another one of these to cancel out. I guess I'll be able to cancel out that extra, but I'm going to have this piece is going to be left over. So I think there's probably a way to do it like that, but I'm going to instead go back and say, well, I have got this internal function here. Okay, so I'm going to let u equal the inside of that square root and see what happens. Okay, so don't forget that we've got all those other substitutions. And that looks much more promising, yes? Not that either one of them is hard, it's figuring out which one you're gonna do. So what do I have on the outside, 1/3? The negative and the negative, and I don't have a U at the bottom, I did that wrong, I had a square root of U, yes? Okay, so that's gonna become U to the -1/2. And so this problem doesn't have any L in it at all, okay? It's not going to be, the antiderivative is not going to be the L in. And I'm putting it here just to remind you, there's probably one mixed into the problems that you have to do tonight, maybe one have to do tomorrow night, it's not an L in. So, what would our antiderivative of this be? U to the -1/2 plus 1 is 1/2, and flip it over, comes 2 over 1, plus c, and so we get 2/3 times the square root of p minus x plus c. So not everything is going to be the substitution let u equal the denominator. Okay? Alrighty? Alright, and that's it. And the rest of the class we're going to spend answering questions about the homework and working the problems on the worksheet. Bye, ladies.